First derivative test for local extrema. Second derivative test chapter 4 Thomas Calculus book. Introduction. In calculus, one of the key objectives is to understand the behavior of functions. Specifically, we are often interested in finding the extrema, the points where a function reaches either a local maximum, the highest point in a neighborhood, or a local minimum, the lowest point in a neighborhood. First derivative test for local extrema. Definition. The first derivative test helps us classify critical points, points where the derivative is zero or undefined, by analyzing the sign of the first derivative around these points. The first derivative of a function provides us with information about the slope of the tangent to better analysis. By studying to identify the changes around a critical point, we can determine whether that test is a local maximum, a local minimum, or neither. Both tests help us determine whether a function is increasing or decreasing at a particular point, and whether that point is a maximum, minimum, or neither. Let's dive into each of these tests and see how they can be applied. How it works. 1. Derivative equal ρ and frame for I radical points also occur vite and the first derivative does not exist. 2 points in the intervals between the critical pelts. The sign of the first derivative L's intervals between the critical points. The psi. U whether the function is increasing or decreasing in those intervals. 3. Classify the critical points. If the derivative changes from positive increasing to negative decreasing around a critical point, then the function has a local maximum at that point. If the derivative changes from negative decreasing to positive increasing around a critical point, then the function has a local minimum at that point. If the critical pedo the pointing c extreme v or negative on both sides of the critical point of the local extrema. Why it works. The first derivative tells us how the function is behaving at any given point. A change in the sign of the derivative from positive to negative or vice versa indicates a change in the direction of the curve. This often corresponds to a local extremum where the function reaches a peak or a valley. Second derivative test for local extrema. Definition. The second derivative test is another method used to classify critical points, but instead of looking at the first derivative, it focuses on the second derivative of the function. The second derivative provides information about the concavity of the function or how the slope of the function is changing. This test is particularly useful for determining whether a critical point corresponds to a local maximum or minimum. How it works. 1. Identify critical points. 1. As with the first derivative test, you start by finding the critical points of the function which occur where the first derivative is 0 or undefined. 2. Evaluate the second derivative. 1. After finding the critical points, you evaluate the second derivative of the function at each critical point. 3. Classify the critical points. 1. If f(x) of x 0 at a critical point, the function is concave up at that point, which means the point is a local minimum. The graph is shaped like a U around the critical point. 2. If f(x) of x O at a critical point, the function is concave down at that point, which means the point is a local maximum. The graph is shaped like an N around the critical point. Why it works. The second derivative gives us information about the curvature of the function. If the second derivative is positive, the function is curving upwards, concave up, and any critical point will be a valley, local minimum. If the second derivative is negative, the function is curving downwards, concave down, and the critical point will be a peak, local maximum. The second derivative test can be quicker than the first derivative test because it directly provides a classification of the critical point without needing to analyze intervals around it. However, it is only applicable when the second derivative is not 0. Comparison of the two tests. First derivative test focuses on the sign change of the first derivative around critical points. Can be used to classify any critical point, but requires checking intervals around each critical point. More versatile, but can involve more steps, especially if there are many critical points. Second derivative test focuses on the value of the second derivative at each critical point. Provides a faster way to classify critical points, but can only be used when the second derivative is non-zero. Inconclusive if the second derivative is 0, in which case the first derivative test may be required. Conclusion. Both the first derivative test and the second derivative test are powerful tools in calculus for identifying local extrema. They each provide different insights into the behavior of a function near its critical points. The first derivative test helps us determine where the function changes direction, and based on this, we can classify the critical points as local maxima, minima, or neither. The second derivative test provides a more direct way of classifying critical points by examining the concavity of the function. It is quick and efficient, but only works when the second derivative is non-zero. Together, these two tests give us a comprehensive toolkit for analyzing the shape and behavior of functions, which is crucial in fields like optimization, physics, economics, and beyond. Understanding how to use these tests allows us to identify key points where a function reaches its local extremes, whether peaks or valleys, leading to better decision-making and analysis.